Hi, welcome to the pre-cal lecture series. And in this video, we're going to take a look chapter 1 practice test. And basically, let's use this practice test, try to kind of summarize the key topics in the chapter 1 and refresh our memory what we learned from the chapter 1 here. All right. So before we start, I need to do some brief review about some key things we will need to use in the chapter 1 practice test here. Okay, so I'm going to stop here and let's go to the chapter 1 practice test. Take a look here. Okay, so for this practice test, we have total, we have 7 problems here. Okay, so for these 7 problems are covered different important topics, right? Okay, so now I'm going to the whiteboard and I'm going to start to review some key concept here. All right, so here is the whiteboard here. Okay, so the first key concept we're going to use is exponents. I think we all know this. So if I have if I have a number, if I said A times A times A, what's that mean? That means this is equal to what? A to the what? Nth power, right? So sorry, not the nth power. So the jumping on so this will be A to the what? Third power. So that's why in general, if you have A times A times A and and if you times this what? N times, right? So if you have A times A, you N times, so what is this one here? This is A to the nth power. And so for the exponents, we have several rules here regarding to the exponents. If you still remember, so we have, so for example, if I have A to the X times A to the Y here. So if the base, right, so these numbers here, we call this the base, right? So those we call this the base. And the top here, we call it the exponents here, right? So this is what we call the exponents here. So, if you multiply the 2 numbers, right? So if they have the same base, then if you times it, it will just be equal to, you add the exponents here. Of course, the key things here, you have to have the same base. Okay, so now how about if you have AX and if you divide the 2 numbers here. So if AX divided by AY, of course here the A and A, they are the same base. Now what is this one going to become to? This one will become to A to the what? X minus Y here, okay? So then in other rules, so this is rule number 1, this is rule number 2. Then the other rules here is number 3. So how about if I have A to the X exponent, then you do the Y exponent. So what is this one will be? This one will be A to the X times Y here. All right, so far so good. Okay, so now also we have some special ones. So how about, if you have A to the negative exponents, right? So if you have the A to the negative, so in order to get rid of this negative sign, basically you just put them into you flip them into the denominator. So this will be to the AX. Okay, so similar here, right? So if I do have 1 of a to the negative y, so if the y is in the denominator, in order to get rid of the denominator, what do? You flip over. So this will be a to the y here. All right, so that's what the exponents here. So in order to get rid of the negative exponent, you either flip the denominator to the, to become the numerator, or you put the numerator here, flip it to the denominator. And then the other ones here, I think we all kind of very familiar. So that will be what? If you have the 0 power here. So what is the 0 powers we have here? We have is what is ones here, right? Okay, so then the other ones here we have is like something like this. So if you have like a to the b's power, right? And then you take the roots of the b's roots, right? So what is this one going to be? This one going to become a. The reason why is like the reason why it is because a to the b to the b's roots, right? So the a to the b is here. B's roots, what is roots mean is 1 over b's, right? Then by rule number 3, so this will be to the a, the b times 1 over b, so it's equal to a1, so it's equal to a here. All right, so that is, that's what is number 6 here. So if you have the same powers here and your roots here, then it will become a here, right? So the same ways here, if you have, if I said a to the 1 over x, that means what is here? That means you have what? X roots here, right? So for examples here, okay, so for example here, if we have, so if we have like a to the square root 1/2, basically what does that mean? It's the square roots of the a's here. All right, so that is the, the brief review we're going to need for the problem number 1. Okay, so let's take a look at our chapter practice, problem number 1 here. Okay, so the problem number 1, part A is here. They want you to simplify. This is 200 minus square roots of the 32 here. Okay, so now in order to do this, right? So I need to kind of take a look. So here, the 200s here, I can divide it to a 2 and 100s, right? So 2 times 100 is equal to 200. And then what is 100? 100 I can divide by 10 times 10. Okay, so the 200th, I can change it to a 2 times 10 to the what? Square, correct? Okay, now the 32 here, let's take a look at 32. The 32, I can say this is a 2 to the what? 2 times 16 will be 32. Then the 16, over here, the square roots, I can say this is a 4 times 4, correct? Okay, so then the 32, I will have 2 times 4 to the square. Okay, now I can simplify it a little bit. So I will say, okay, now I have square roots of 200. That means I have 2 times 10 to the 2, and 200 square roots is what is 1/2. So the same for the 32s here, right? So the 32, I can simplify it as 2 times 4 to the square to the 1/2. So remember by the, we just review. So this will be kind of like a similar like distributive rules. And then you will have in here, so what is in here? So you will have, this is 2 to the 1/2. Then this is 10 to the 2 to the 1/2. And this is 2 to the 1/2. And this is 4 to the 2 to the 1/2. Right? Okay, so what is this one going to be? 2 times 1/2 is 1, right? So it's a cancel. So that means you will have 10 to the square. So what is this one here? This is 2 to the 1/2. That's the square root of the 2. So the same way is here. For this one, 2 and 1/2 is cancelled. So what is this one going to come out? This will be 4. And the same way, this one is the square root of the 2. Okay, so now I simplify this to the 10 square root of the 2 minus 4 square root of the 2. So how many square roots of the 2 I have here? I have 6 square roots of what? Square roots of the 2's, right? So you can only minus 2 radical if they have the same value. If this one's here, if for example, if this is 4 square roots of the 5, then you cannot minus it. All right. So the reason why you can minus is because what? Because both of them here have square roots of the 2's here. So far, so good? Okay, great. Okay, now let's take a look at part B here, right? So the part B here. The part B, it asks you, this is a 3a cubed, right? B cubed. And then this is 4a b square to the square. Okay, so the first thing's here, and this parenthesis, so here, this is really the ones, right? So that's why I can break it. This is 3a cubed, b cubed, right? Okay. So now from the previous review, so we know this one's here. That means you kind of distributive property. You need to go to the exponents for all of the numbers inside. So basically you times what? 4 to the what? 4 to the square. Then a to the square, right? What is the b here? Is 2 times 2 will be what? B to the what? B to the 4th. And then remember in the review, we can only combine the similar terms here. Okay, so the first things here I'm going to do is I'm combining only the number. So 3, so what is 4 to the square? 4 to the square is 16, right? So what is 3 and 16? Is 40 what? Is 48, correct? So now, the next similar terms I'm going to do is a here, right? So this is a, and this is a to the square. So this is a cubed times a square. So remember the review, what is going to be? You what? If they have the same base, you multiply them. What are going to be? You add the exponents, right? So what is here? It's a 5. Okay, so now let's take a look. This one's here, the B. This is my B. This is my B, right? So this is B cubed times B fourths. The same way, they have the same base. So what do you need to do? So what do you do? You add them, right? So 3 add 4 is what? It's a 7 here. Right? So this is my final answers here. So that's why, so it's 48, a to the 5th, and b to the what? B to the 4th, right? So this will, I'm sorry, b to the 7th, right? So this is the final answers here, right? So this is b to the 7th, yeah. So remember, right, the exponents here. Okay, now let's take a look at the problem number 3. Part A, part C here, I'm sorry, not number 3, is the part C here, right? All right, so the part C, all right? So the part C, this one's here, it will give you 3x to the 3/2 and the 1 to the 3rd x squared minus y to the negative 1/2, and here this is a negative 2. All right, there are many different ways that you can do it. Or you can do the first thing. You say, hey, this is a negative exponent. We just learned from the review, if this is a negative exponent, in order to get rid of the negative exponents, what do you need to do? you can flip it, right, to the denominator. So that means I can put the whole thing in the denominator. So this is 3x 3/2 y cubed x squared y negative 1/2. Boom, you put everything in here. Can you? Oh, yes, right? And now, because this is a fraction, so do you remember, in the algebra, if you have like a over b and c over d in the fraction, what you can do, this is a over b, you can flip the bottoms, right? So here the top is 1, it's just 1 minus 1, so you can 1 over 1, so you can flip the top. So if I flip the top, right, so that means that means this one's here going to where? Going to be top, right? I flipped it, all right? Okay, so now let's see here. So this is x squared y negative 1/2 to the square. Then the bottom here is 3x 3/2 y cubed to the square, right? So basically I simplify the fraction. Now, what is the next step we need to do? We need to kind of use a distributive property, get the exponents out, get the exponents inside. So remember, right, need to go to every terms here, right? Okay, so let's try. So 2 to the x2, so it's a what? X to the what? X4, right? Okay, so 2 times negative 1/2. So what is here? Negative 1. So far, so good? Okay, so then 2 to the 3. So what is this? 2 to the 3? So it's 3 to the square. Okay, 2 times 3/2. What is here? Third. So x third, right? Then 2 times 3 is a what? It's the y over 6. And they say we don't want to have negative exponents. And now the only negative exponents is in here, y to the negative 1. So what can I do? Flip it, like we talk about, flip it, right? So this is x4, then this is 3 to the square is 9, then this is x to the third, right? So this is x to the third, and then this is y to the 6th. You flip this one down. So what is here? This one down here. This one is 1, right? Okay, now let's simplify it. Okay, so now take a look, combine a similar term. This is x to the 4th and x to the 3rd. So x to the 4th and x to the 3rd, what is that? Is the x of what? 4 minus 3, right? So it's x. So this will be 9, have an x here. Okay, now take a look at this one. This is y6 times y1. So what is here is y to the what? Y to the 7th, right? So this will be our final answer, right? So it's not too bad, right? Okay, so the part B is here. Part B, let's take a look at part D here. It's a long problem here, huh? Okay, so part D, they want to simplify that. So this is x squared plus 3x plus 2. And this is x squared minus x minus 2. So when we talk about the simplify, so basically what skill we use? Factoring. Right? I don't know how your high school teacher, how did your high school teacher teach you about the factory? And I assume we all know how to factor because this is a very basic skill. So basically we say we break it into a 2, right? So this is x, right? So x times x is x squared. So what is 2? I can break it into 2 and 1s, right? So 2 times x is 2 times 1 is 2, right? Then here, this is 3x, so I can put a plus and a plus. If you don't know how do I factor this one, then you really need to go back to review the factoring, okay? So the same ones here, this one is a very basic one. So the same one, the factor, this is xx. Then here's 2, here's 1, because here's negative. I need to decide where the negative go, because here is negative. I have a negative x's here, so I put a negative here, plus 1 here, right? So plus 1 times negative 2 is negative 2. Then plus x and the negative 2s give you the negative x. Let's see, do we have anything we can cancel? Oh yes, this one, right? So x plus 1, x plus 1. So what is the final answers here? So the final answer will be what? X plus 2 over x minus 2. Good. Okay. Now let's take a look at part E here. Okay. So part E. Okay. So part E, this is x squared minus 4, then minus x plus 1 and x plus 2. So the part E want to test you two things. First thing is, do you know how to factor? All right. Then the second thing is, when you try to combine the two fractions, what do we need to know? Do you know how to find the what? We need to know how to find the common denominator. Right? So this problem try to test you to see you know how to do these two things here. Okay. And also, I want to write a very important factors formulas here. We use it a lot. So it's a squared, So it's a squared minus b squared. This is equal to the a minus b, a plus b here, right? We're going to use this factor in formula a lot. So I strongly recommend you try to put it into a piece of the paper as your formula so you know a squared minus b squared is equal to a minus b times a plus b here. Okay, so now let's take a look. Okay, so first things, let's simplify it. So this is x squared. So what is x squared minus 4 here? Remember the 4 is equal to what is 2 to the square, right? So it's x squared minus 2 to the square. So I can use the a squared minus b squared formula. So what is here? This is x minus 2 and x plus 2. Then minus, this is x plus 1, and this is x plus 2, right? Okay, now let's need to find the common denominator. Okay, so the common denominator, so take a look here. They have x plus 2 here. Oh, that's good. I have x plus 2 here. But I have one extra, x minus 2. So I know my common denominator will be what? This is x minus 2, x plus 2, then minus x minus 2, x plus 2. This is my common denominator. Then look at your first fractions, right? So this is x squared. The common denominator is x minus 2, x plus 2. It's the same as here, so nothing changes. So I say it's x squared. Then take a look at the second fraction. The second fraction, the original denominator is x plus 2. Now for the common denominator, I add x minus 2. So what I need to do here, I need to times the x minus 2, right? And then times what is original, x plus 1. Did you see here? The reason why I need to times it is because, original only have x plus 2's, right? So now you add what? You add x minus 2. So you need to times x minus 2 here. Okay, now let's see our algebra. So this is x minus 2, x plus 2. Okay, so this is x squared, then minus. So here, be very careful, right, about the negative sign here. So put a parenthesis, that's the safest way. Now, what you need to do here, FOIL it, correct? Right, so you FOIL it, right? So I assume, and everybody know how to FOIL it. Okay, so x times x is x squared. X times 1 is plus x, minus 2x. Minus 2 times 1 is minus 2. So far, so good? All right. Okay, so if you want, you can simplify it a little bit. So this is x minus 2. This is x plus 2. So this one's here. What do you combine? And these two going to become 2? This is minus x, right? X minus 2x is minus x. Okay, now let's break the parentheses. So this is x squared minus x squared, right? Remember, here is a lot of students make mistake. This negative sign has to go for every term inside parentheses, right? Okay, so minus x, now we simplify the minus x. So minus minus is what? It's a plus x. And this is a minus, so minus is what? Plus 2. So here is the place, like I said, most of the students going to make a mistake. Yes, you know, like when they do the negative sign inside the parentheses, sometimes they only do it to the first term. Remember, you need to do to every term. X squared cancel. So what do you have here? This is x plus 2, and this is x minus 2, and this is x plus 2. Wow. Whoa, good, cool. X plus 2, x plus 2. I can cancel. And what is here? This is x minus 2. It's good. All right, so let's take a look next here. Next is part F here. All right, so the part F here, this is y over x minus x over y. And this is 1 over y minus 1 over x. All right, so what is the part F try to do? Okay, so part F try to do two things. First thing is also because you need to combine the fractions. So what do we need to find? We need to find a common denominator. Right, see here. Right, so that's why we need to find a common denominator. What is the second thing? This problem try to test you how to simplify. We already did that. So how to simplify if you have a complicated function, fraction, like it's AB. So AB is a small fractions on the top, and then you have a fraction on the bottom. So how do you simplify it? You keep the top, then you times what happened? You flip the bottoms, right? So it's D over C. So that's the two things this problem try to tell us. All right, so let's take a look, okay? So let's take a look here. You know, when you do those things, as soon as you be very careful and not messy, and so you won't make the silly mistake. Okay, so the first ones here, let's take a look. This is X, this is Y, right? So what will be my common denominator? Well, will be XY, right? So here, I find that this is XY here. Okay, take a look, the first ones here, right? So this was my original, so this is Y. Okay, so original, this one's only have X, correct? Now you have XY. So what I need to times 1 on the top here, let me try to use a different color. So I need to get Y, right? Because you got 1 extra Y here, right? So that's why I'm color coding here, right? So you need Y. So the same way for the second ones here, the original, what do you have here? You have X, right? Okay, so now you have XY. And the original here's Y. Now you have 1 extra what? 1 extra what? 1 extra X. So what you need to do here, you need to times X. Cool? Okay, now let's take a look at the bottom here. The bottom is also the common denominator is XY. Okay, so here, original, this is 1, right? So now, in here, the original here is what? Original is Y, right? Original is Y. Now you have extra what? X here, right? So what do you need to do here? You need to times X here. A better match what the notation I use. Original is Y, so you have extra X, so you times X. So here, the original is, okay, so here, let's make sure this is 1 as original. And then original is x, so you have extra y here. So that's why you need to times y. Right, so you see my color coding? Okay, so now I can combine it. Okay, so the top will be xy. So what is this 2 will become 2? This will be y squared minus what is this 2? X squared. Okay, so here this is xy. So what is this 2? Is x minus y, right? Okay, now I'm flipping, right? So using the, so this is a y squared minus x squared, xy. I flip. So switch here. This is xy. This is x minus y. All right. So boom, boom. These two cancel. So I have y squared minus x squared over x minus y. Remember the formula I show you? I say, hey, you need to remember this formula, right? So it's a minus b times a plus b here. Okay, so now I have y squared minus x squared, right? So this is my a, this is my b. So what is this one I can simplify to? This one I can simplify to a minus b, so it's y minus x times what? Y plus x. And this is x minus y. Whoa, I see something very similar here. Look here, this is y minus x. This is x minus y. What is the difference, Celine? It's different than a negative number. So if I take a negative number out, I can say this is x minus 1, x minus y, and this is x plus y, right? So I just factor the, so this one's here, I just factor the negative 1 out, right? Okay, so the bottom still is x minus y. So what happened here? Boom, boom, you cancel. So what is the final answer? The final answer is will be negative x plus 1. Okay, all right. Let's take a look at the problem number 2 here, all right? Okay, so finally we finished the six parts in the problem number 1. Okay, so the problem number 2 is here. They want you to rationalize the denominator. Okay, so this is the square roots of the 10. So this is square roots of the 5 minus 2. So they want you to rationalize. What is the rationalize means? That means no square roots, no radical. Or we call this a square root. Well, maybe it's not a square root, just you can do cube roots also, right? So basically say no roots on the in the denominator. So that's what is rationalize mean in the denominator. So how do you do it? You times, you multiply, conjugate. You guys still remember what is the conjugate? Conjugate is just the opposite sign. If you have a minus, you use a plus. If you have a plus, you use minus. Okay, so let's take a look here. So this is the square root of the 10, and this is the square root of the 5 minus 2. So the conjugate will just be, what is the conjugate? What is the conjugate means? Okay, so this will be square root of the 5. So here's a minus, so I plus 2, all right? You cannot just times the denominator. If you times anything in the denominator, you need to do the same thing, you times on the numerator, okay? So take a look at what happened to the denominator. So this is a minus b times a plus b, right? So if you let this is a A, this is B. So see here, so the denominator simplify to the A minus B times A plus B. So remember the formula I wrote here before? It's A squared minus B squared. What is this one? It's A minus B times A plus B. So can you tell me what is the denominator going to be? Will be A squared, right? So it's the square root of the 5, the square minus 2 to the square. Correct? A squared minus B squared. Then the top, what you need to do, you do what? You do the, so the top will be the square root of the 10 times the 5 plus 2 square root of, right? Okay, so now let's simplify. The square root of the 5 is 5 minus 2 to the square is what? 2 to the square will be what? Will be 4, right? Okay, so then the top here, what I need to do here, I need to do the distributive properties, right? So I will distribute it. So square root of 10 times square root of 5 is what? It's a square root of what? 50. Then plus 2, the square root of 10. All right? Okay, now let's take a look at 50. Can I simplify it? We did this in the problem number 1, part A. 50, I can say this is 2 to what? 25. Oh, good. 25. I have a what here? I have 5 and 5 here. Right? So now the square root of the 50, I can change that to a square root of the 2 times 5 to the square. So I can change this 2 times 5 to the square to the 1/2, right? So this will be 2 to 1/2 times 5, right? Because this one and this become cancel. Okay, so now this one, 5 times 2 to the 1/2 is square root of 2. Okay, so my answer is 5 minus 1 is 1. So this will be 5 square root of the 2 plus 2 square root of the 10. Can I do anything like a 2 and this 2? No, I cannot. Right? So I cannot because they have a different square roots. So I cannot do it. So this will be my final answers here. All right. So we did the 2 problems for this video. I don't want this video last too long. Okay, so we're going to stop here and we are going to continue our next problems, problem number 3 in the next videos here. All right, that's it. It's nice to talk to you and hope that this can help you to prepare for your exams here and so that you'll be able to also know what type of the problems are important we cover in the chapter 1 here. All right, that's it. Okay, so it's nice to talk to you and looking forward to talk to you on the second part and let's continue work on the problem number 3. All right, you have a good day and talk to you later. All right, bye-bye.